3 pieces, x squared for x less than 0, -3 for x equals 0, and -2x plus 3 for x greater than 0. Perfect pick. Where are you guys? Where is my share button? I lost my share button. How can I lose my share button? Where is my share button? Okay, class is over. I can't stop sharing. Where is it? What happened? I lost my share button. How can I lose my share button? Ah, here it is. Good. Awesome. So this is a piecewise defined function. Yes, it happens that it has 3 pieces. Fine. And first of all, I have to start every time I'm asked to graph a function. My first step must be domain at all times. Remember, except here, I kept quiet because the domain is all real numbers. But here I did not. I said we always have to look at, even if we don't graph, we still have to look at the domain. Here I was not quiet. I asked from the beginning, what is going on here? And you said, well, x cannot be 1. Here you said 4 minus x has to be greater than or equal to 0 because it's that function that I have to worry about, like this one. So when I graph the piecewise defined function, I have to worry about the domain. So let's worry about the domain. Now, can anyone give us the interval notation for this? Just look at this, x less than 0, and just give me the interval notation. Anyone? Do you remember the interval notation? Do you want me to explain the interval notation, or anyone remembers the interval notation?
Would it be parentheses negative infinity comma
of course
0?
Of course, that's it. X less than 0 means from negative infinity to 0. This I don't have anything to write. This is it. But what about the interval notation for this? Can anyone give us the interval notation for this?
Would it be 0 and infinity?
Awesome. Of course, Nathan. Thank you. Excellent. Now I can discover the domain. Let's look at this, and this, and this. Can anyone figure out the domain for this function?
Negative infinity, positive.
Brilliant. Nothing is missing. Awesome. Who said that?
Sierra.
Thank you. That's it. Thank you, Nathan. Thank you, Sierra. Excellent. Nothing is missing. I have to the left of 0, I have 0, and I have everything to the right of 0. Awesome. We're going to create this table, x and y, or function, f of x. We will put the domain in there. And now 0 is a key value. So 0 has to be in the table. No matter what, 0 will be in the table. And notice that I have a left parenthesis here, facing this way, and a right parenthesis here, facing that way. And they're all the equal symbol, and all these parentheses are at 0. So under 0, I have to write -3. There is no discussion there. But I also have to present to the left of -3 this left parenthesis, and to the right of -3 this right parenthesis. Now I make myself some notes. On this interval between negative infinity and 0, which function will I use?
Quadratic.
Yes, the x squared. And you can say, wait a minute, why are you writing them here? Don't you see them there? Yes. However, sometimes they are trying to trick us. These may not be in the correct order, so be very careful. I know this is silly, but between 0 and infinity, which function will I write?
-2x plus 3.
Very good, awesome. Thank you very much. Good. So quadratic, I will plug in 0 and put a number here. And you should say no. No. You cannot plug in 0 here because 0 is not here. 0 is here. But I'll say then to you, you're right. I am not allowed to plug in 0. But if I'm not allowed to plug in 0, I will ask you to plug in negative 0.000000000000001. Do you want to plug in 0, this number in there from the left-hand side of 0? No, you don't. So when you plug in 0, we write it in here, inside the parenthesis, and we know that this point will be what kind of point? Full or open? Will it be a full point or an open point? Okay, we'll see. That's okay. We'll do it together in a minute. So let's also plug in -1, a number between these two. Can anyone plug in -1 and tell me what to write?
A positive.
Very good, +1, good. Moving on to the other side, let's plug in 0. And I know you will say, no, no, no. Okay, but if you don't plug in 0, then you'll have to plug in 0.00000000001, and nobody wants to do that. So if we plug in 0, we'll write a number inside the parenthesis. What number do I write inside of parenthesis?
3.
Awesome. So let's look at 1. What do I get when x is 1?
1.
Yes, I do get 1. And I already see that negative 2x plus 3 equals 0 means x equals 3 over 2 or 1.5, and I get the 0. I always look for the x and y intercepts. Good. So now let's see how we graph this. Stop me if you have questions anytime. So I see 0, comma 0. Okay, so this is this point, but it's an open point. Let me erase the origin from here so you don't get confused with this. I can put it in later when we finish. So this is it's not a full point because I wasn't allowed to plug in 0 in this function. So that's why 0, comma 0 is an open point. On the other side, I have -1, comma 1. -1, comma 1, which is absolutely a full point. I know how to graph x squared. It's this graph. But I can only graph it from -infinity to 0. Notice that you do not have to do this, but I put the red marker aside. The middle piece says when x is 0, y is -3. Fine. 1, 2, 3, and this is a full point. Okay, this is the middle part, so I put that marker away as well. Okay, now I'm going to use green. This one says 0, comma 3, but this is again an open point. Why? Because I was not allowed to plug in 0 into -2x plus 3. So 0, comma 1, 2, 3, it's an open point. And then 1, comma 1, and then 1.5, comma 0. And this is it. Notice 3 different colors. Why? Because they cannot overlap. If you continue and extend this function to this side, and you continue this function to the left, that is not a function by the vertical line test. Can anyone give us the range? Because we are discussing now the range and domain. So again, I see, how do I find the domain? Can I draw, or imagine I draw vertical lines? Do all these vertical lines cross the function? Yes. From -infinity to infinity, these vertical lines cross the function in only one point. So the domain is indeed, as we discovered, all real numbers. Now I'm doing the same thing, but with horizontal lines. Does this horizontal line cross the function? Yes, because this goes away, it goes all the way, and this goes all the way. Yes, 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 yes. It crosses at least in one point at all times. So what would be the range of this function then?
Would it be all real numbers again?
Yes, of course. Negative infinity to infinity. And now you can say, why is this so important? You will see in chapter 1 why this kind of function is so important. Any questions for me before we look at other problems? Any questions? Okay, I will share my screen. I hope I'm not losing this share button again. And can anyone give us or tell us whether 45 is the graph of a function? It says, use the vertical line test to determine whether each graph is of a function or not. Is 45 a function?
No.
No, by the vertical line test is not a function. Is 46 a function?
Yes.
Oh,
Yes.
awesome. Is 48 a function?
No.
No. Very good. By the vertical line test is not a function. What about 51? Yes. Good. So a refresher for you, how anyone remembers how do we call this vertical line that the function never crosses? This vertical line, this vertical line.
The asymptote.
Vertical asymptote. Okay, awesome, brilliant. Okay. Vertical asymptotes. I'd like to move on to 32. 32. Any questions? Anyone? Please, any questions? Okay, here we have a bunch of problems in which we're asked to find domain. Find domain for a graph, and then find the x values such that f of x is 2 and the range. Okay, so let's choose any graph you would like from 21 through 32. So let's choose a graph and analyze it and answer the questions. Okay, I will choose 25. For 25, can anyone try the domain? So 25 on page 32. Domain. Can anyone give us a domain for 25?
-2 to 4.
-2 to 4 with brackets or parentheses?
Brackets.
Yes, because the points are full. If we had, I'm going to stop sharing for a second. If we had something like this, for example, or closed on one side and open on the other, I would have written -2 open parenthesis, comma 4, using the same numbers. 4 here with a bracket because the point exists, and the point does not exist, so x cannot be -2. Good. Moving on. Can anyone give us the range of this function?
Would it be all real numbers?
The range. We start from below. We imagine you cross it with horizontal lines. Cross it, cross it, cross it, cross it, cross it. No, no, no. Nothing here. Nothing here.
-3 to 3.
-3 to 3. The range is bracket -3 to +3 because the points are full. They're also asking us to find the x values such that f of x, they also want f of 1, so let me write f of 1 also, and they also want f of x equals 2. So first of all, let's discuss this for a moment. So the graph of this function is from -2 to 4. Bear with me, something like this. From -2 to 4. So these are two separate questions. So this is question A and this is question C, I think. F of 1 tells us that x equals 1, and remember what we discussed last time, x equals 1 is a vertical line. So imagine, or just draw, imagine that you draw the function, the vertical line x equals 1. Does it cross the graph? Yes, it does. And now I have to read the y value. So let's do f of 1. Who would like to help with f of 1?
Is it -1?
It is -1. Awesome. Who was that?
Sorry.
Thank you. Do we all agree with f of 1 being -1?
Yes.
Yes.
Any questions? Okay, now let me explain the other part. Okay, now we're talking about f of x equals 2. But when we say f of x equals 2, we really mean y equals 2. And we discussed that y equals 2 is an altitude. Y equals 2 at 2. 1, 2. So this is my y equals 2. Does it cross the graph? Yes. Of course, this is not, we're not going to read from my graph. Let's say it crosses here. And then I will read the corresponding x value. So y equals 2 is a horizontal line, altitude, as we discussed last time. It crosses the graph in a point, and I will read the corresponding x value. So now let's look at, okay, here it is. For f of x equals 2, I imagine that I draw a horizontal line through x equals 2. Forgive me, of course, through y equals 2. It crosses the graph at this point, and I will be reading the x value.
X is 3.
X is 3. Awesome. Well done. So x equals 3. Because we read from which point? Can anyone give us the point we just read from?
Three, 2.
Of course, x is always first, y is second. Awesome. Great job. Okay, let's look at a word problem, because that's what the course is all about. And we already discussed this, but if you'd like to choose anything from 33 through 52, and then look at a word problem. 33 through 52.
48.
Which one?
48.
48. There is nothing we can write for 48. What will be the domain for 48? It's a polynomial function, and we said all polynomial functions have what domain?
-infinity, +infinity.
Exactly. So which page am I on? I'm on page 9. No, 8. So I'm just going to stop sharing for 1 second. Domain for polynomials. Always -infinity to infinity. No worries whatsoever. I sleep tight. When I see a polynomial, I don't have any problem. So let's share the screen again. So